Hi everyone, in this video we'll be taking a look at a question on sequence and series. For part A of this question, we have given that the summation of r squared equal to n over 6, n plus 1, 2n plus 1. Perhaps we'll be making use of this information given to us later on. And our objective for this question is to evaluate this particular summation, and you have to express your final answer in terms of n. Summation of r equal to minus n to n of r plus 1, r plus 3. I would say that it's pretty rare to see a summation question that start off with a negative values. Usually you'll be only seeing like a value that start from 1 or a positive value. But anyway, let's see what we can do about this. In fact, my initial approach for doing this question is by doing substitution, because I see that perhaps I might be making use of this expression here, and in order to use this, my r should start from 1. Therefore, I will be using a bit of substitution to replace r with something else to change this into 1. Although I managed to solve this question, but actually I feel that the solution is a bit long, and the algebraic manipulation part of it gets very complicated. So let's see what we can do about this to have an easier method to solve this. My first approach probably will be doing an expansion for this first. I will end up with r squared plus 4r plus 3. I will just split up the summation. I'll get this summation of r squared. 4 is a constant, I can just factorize out. And finally, we will have summation of a 3. Although this 3 we can just factorize out, but I think it's pretty okay just to leave it in this format here. Now let's try to analyze this expression term by term. Looking at this, right, sometimes I will feel that if you are stuck or do not know how to approach this, maybe it might be a good idea if you can sub in the first few terms first. When you are subbing in the first few terms and the last term, sometimes you'll be able to identify a certain pattern in it. And hopefully from there, we have a clearer direction how to approach this question. And here, maybe I'll just sub in the first term, which is minus n. I'll get minus n squared. And when you increase another term, you get minus n plus 1. I'll get minus n plus 1 squared, and minus n plus 2 squared, and all the way until I will just stop halfway first, and halfway actually is the value of r equal to 0. But I don't think it's necessary to put r equal to 0 inside, because when r equal to 0, it will just be a 0 value, so it's not necessary to put in. And the term that is before 0 is actually minus 1, and the term before that is minus 2. Maybe I'll just indicate the last two terms, and I will get this, and it will carry on all the way until the first two of the positive term, which is 1 squared and 2 squared, and the last 3 term will just be equal to n minus 2 squared plus n minus 1 squared plus n squared. Although it's not really necessary to write down such a long series, if you can identify the pattern, you can just 1 or 2 terms will be sufficient. But for here, maybe I will just write it out clearly. And for this, right, if you were to put in another first few terms, okay, let me just write another row. Take note that this actually is everything together at the same time. First term is minus n, I'll get minus n. And second term is minus n plus 1. And third term is minus n plus 2. It looks similar to this, except there's no square for this. And same thing here, plus I will get a minus 2, minus 1. And the 0th term, I will not be writing it, it's just unnecessary. Then after that, it will just be 1, 2, all the way until n minus 2, n minus 1, plus n. If you can recognize something, right, what happened? When I'm putting in the values from minus n all the way to 0, I will get this particular expression here, which involves all the negative values of n, minus n, minus n, minus n, and so on. After that, when it passes the 0th term, it will end up to be positive value, 1, 2, 3, all the way until n minus 2, n minus 1, n. And which happens to be the exact mirror image of the negative terms. If we be looking at one by one, this is cancelled. This is also cancelled. And similarly, this will be also cancelled off with my this. This will be cancelled off with my this. This will be cancelled off with my this. Right? If you are unable to see this, you can actually think of this by factorizing out the minus term here. I will left with n minus 1, which can be cancelled out with this. Likewise for this particular term and so on. Okay, and finally, to tackle a constant term is pretty straightforward. What we need to do is just to use the last term minus the first term plus 1 to determine the number of terms, and I will just use the number of terms to multiply by the value of the constant. I'll just get a plus last term minus the first term plus 1 multiplied by 3. Right now, maybe I can just shift my working here. And if you can notice, right, what happened here, right, if it's like a minus n squared plus minus n plus 1, if you will be factorizing out the minus here, the minus actually is so-called gone because of the square here. I will just left with like an n squared. This one, if I take out the minus, I square it, I will left with like a n minus 1 squared. Likewise, for this, if you take out the minus, when you square it, you only left with n minus 2 squared and so on. This is also left with 2 squared, 1 squared. In fact, all these negative terms is actually exactly the same as all the positive terms. Right? Therefore, I can rewrite this expression to be just twice of summation of r equal to, you can write it as r equal to 0, but it's not necessary because the value of the 0 term again is 0, so it's not necessary. I just put it as r equal to 1, r squared, and this I already determined that the value is 0. And this will just be here. This will end up to become 2n plus 1. I'll just get 3 times of 2n plus 1. And now we can finally make use of our information given to us. I can just replace this particular term with what they have given us. I'll just get n over 6, n plus 1, 2n plus 1, plus 3, 2n plus 1. Final answer, I will end up with this and this. Okay, in part B of the question, it says that using standard series from the list of formula MF27, find the range of values of x for which the series of this particular summation converges. State the sum to infinity in terms of x. Let us write down the summation first. Okay, when the question is mentioning on the standard series, what they are mentioning here is actually, let's refer to the standard series. Okay, this is our MF27. There are actually 4 standard series given in our formula list. The first one is the exponential x, second one is sine x, third one is the cos x, and the last one is the ln 1 plus x. At first note, actually, I already suspect that I probably will be using the last one, which is the ln, because look at the general term for each of this standard series. And the one that is closer to it, right, is the last one. Right, anyhow, let's say if you are not able to see it so quickly, maybe again we will just sub in the first few terms and try to see which one will match with it the closest. When r equal to 1, when I sub in, I get minus 1 squared. I will get x, 1, 2. Alright, when r equal to 2, I sub in 2, I'll get a 3, x, 2. Sub in 2, I'll get a 2. I'll get a 2 squared. Maybe I'll just sub in one more. R equal to 3 minus 1, 4. x3 over 3 to 3 plus all the way until infinity. Maybe I can just do a bit of simplification. Here I will left with x over 2. Here I'll get minus. Here I will get x. I'll get my x over 2 square over 2. And here I will get plus x over 2 cube over 3 plus dot 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 dot. Alright, the reason why I want to express into this form is to get it as close to this particular first 3 terms as possible. By comparison a bit, can you see basically I'm just replacing my x with x over 2? Right? In fact, this entire expression is the same as this particular expression here, just replacing the x with x over 2. Right? In fact, this, if you can see right from the start, it can be rewritten as this. Minus 1 r plus 1 over r. This is x to the power r, this is 2 to the power r. Is x to the power 2, x over 2 to the power of r. It's exactly the same as this, except we are replacing the x with x over 2. So therefore, this entire expression here can be rewritten as a ln bracket 1 plus x over 2. Alright, but the first part of the question was asking us to find the range of values for x for which this particular expression converges. And if you refer back to our formula list, in fact, there's a range of expansion in which is valid for ln 1 plus x, which is this particular range here. Minus 1, x, and 1. And in this particular scenario, I will just be replacing my x with x over 2. Therefore, the range of values of x for this particular series will be given by between minus 1, x over 2, and 1. And just multiply throughout by 2, I will left with minus 2 to 2. Take note that this does not have equal. This one will have a equal. And I know that this particular whole series can be rewritten as this. If you want, you can just do a bit more simplification. I'll end up with this. And in fact, this will be my final answer for my part B, which is the sum to infinity of this particular series here. Right, so that will be my answer for my part B.